Hello students, we are discussing second module, that is pumps and actuators. So already we have seen different types of pumps which are used. Piston pumps we have seen, gear pump we have seen, external gear pump we have seen, internal gear pumps we have seen. We have seen the working of the pumps. Now we will discuss the actuators. So in the circuit diagram we have shown the actuator, rotary actuator. A circle with the two heads that indicates the hydraulic actuator or hydraulic motor. Rotary actuator or hydraulic motor, it is also known as motor. So hydraulic motor, in the second figure was shown a hydraulic motor with a shaft and a pulley connected with the load using the rope. So when hydraulic motor starts to rotate, the load is taken up, is lifted up. So now let us see how this motor is going to work by using this circuit. So in the circuit you have shown reservoir, filter, pump. Already we have seen different types of pumps. So any type of pump we can connect here, gear pump, or it may be vane pump, or it may be a piston pumps, axial piston pumps, shaft plate type, or radial type, or bent axis type pump. So next, pressure relief valve is there, where we can set the pressure required in the system, pressure required to do that work, to lift that load by the motor. So next we have shown direction control valve, DCV. So in one position of the DCV, the motor is going to rotate in clockwise direction, and another position of the valve, the motor is going to rotate in anti-clockwise direction. A circle with the arrowheads indicates, that is a symbol for hydraulic motor. So we have shown the motor along with the pulley and the load. So this is hydraulic motor connected to the pulley and the rope and the load. So here we have shown actuator, linear type of actuator. So in the last figure we have shown a motor or rotary actuator. This is the linear actuator, which is used just example we are given of service station. To lift the load is nothing but is the four-wheeler. We want to lift that load. So when high pressure enters at the bottom port of the cylinder, the load is lifted, the car is lifted. When the high pressure oil enters the top side of the cylinder, it is taken down. So in one position of the valve, the load is moving up, and in another position of the valve, direction control valve, the load is moving down. So here we have shown the linear actuator. In last circuit we have shown rotary actuator. So here also, if you see the circuit diagram, reservoir which stores the oil, filter to filter the oil, next pump we have shown. So already we have discussed different types of pumps. So pump, to run the pump we require the electric motor. The oil pumped by the pump, it will move towards the pressure relief valve and direction control valve, and from direction control valve it will move towards the actuator. So when high pressure oil enters the actuator, extension will take place. When you change the direction of the oil in direction control valve, so the linear actuator starts to retract. So once in one direction it is going to extend, and in another position of the valve it is going to retract. So here we have shown the linear actuator. On linear actuator there is a load, and pressure we are going to set according to the load on the actuator. So work is done by the actuator here. In a hydraulic system, pumps transmit the fluid. So this is the single acting cylinder or actuator, linear actuator. In hydraulic system, pumps transmit the fluid in the lines by continuous pumping action and increase in the fluid pressure. So pump increases the fluid pressure, is caused by resistance to the load. In hydraulic system, pumps transmit the fluid in the lines. So pumps transmit the fluid in the lines or system by continuous pumping action, and an increase in the fluid pressure is caused by resistance to the load. The mechanical energy input through a prime mover is converted into fluid power by the pumps. The fluid power in turn is converted back into mechanical energy by the hydraulic actuators and motors. So already we have shown circuit diagrams using linear actuators and motors. This fluid power in turn is converted back into mechanical energy to do the work into mechanical energy by hydraulic actuators and motors. The power developed at the actuator depends on the flow rate, and power developed force acting depends upon the flow rate, the pressure pressure drop across the actuator, and the overall efficiency. There are three types of hydraulic actuators: linear actuators, or also known as hydraulic cylinders. So inside the cylinders you can see the piston, cylinder and piston arrangement. Rotary actuators, they are known as hydraulic motors. Again, rotary actuators, limited angle or semi-rotary actuators. So complete rotation also available, and semi-rotary actuators are also available. Linear actuators are nothing but hydraulic cylinders which produce straight line motion. So they produce the straight line motion, that's why they are known as linear actuators. The linear displacement achieved in a hydraulic cylinder depends on the stroke length. The linear displacement achieved in the hydraulic cylinder depends upon the stroke length, hence the length of the actuator itself. These actuators are generally termed as hydraulic cylinders. Other specific terms like rams and jacks are also used for the hydraulic actuators. You can say it as a rams and jacks depending upon their end use. The term ram is used for a single acting cylinder that causes linear motion in horizontal plane. For example, hydraulic ram used in a die casting machine. The term jack is used to refer to a hydraulic cylinder that is used to lift loads. For example, the hydraulic jack used to lift the car to change tires. Rotary actuators or hydraulic motors. Rotary actuators are nothing but the hydraulic motors and are meant to produce a continuous rotational motion. Semi-rotary actuators. These are also hydraulic devices used to produce rotating motion, but the motion is non-continuous and is limited to less than one revolution, that is less than 360 degrees. These are used to produce oscillatory motions in mechanisms. So in figure you can see a single acting cylinder. A single acting cylinder is the basic linear actuator widely used in hydraulic system to produce linear motion in one direction. It consists of cylinder, piston rod, and an inlet port for the fluid at the piston end. The cylinder barrel is machined to high surface finish so as to form a closed fitting with piston. The piston is fitted with the rubber seals or metal rings to make the mating leak proof. The piston rod attached to the piston is supported with the bearings at the rod end of the cylinder as shown in figure. A seal in the rod helps in reducing any leakages from the cylinder. A drain hole is provided in the cylinder at the rod end which is let out to the sump. This helps in removing the leaked oil across the piston seal. In the absence of the drain hole, the oil built up at the rod end will gradually reduce the effective stroke length. In operation, the fluid is let in through the inlet port at the cylinder end as the pressure is built up in the cylinder. As the pressure is built up in the cylinder, a force is exerted on the piston. So force means it is the pressure of the oil into the area of the piston. So that is converted into force. Force means it is the pressure into area. A force is exerted on the piston which in turn causes the linear motion of piston. This is termed extension. In single acting cylinder, the retraction is not by hydraulic means but with the help of a compression spring or under the influence of gravity with the external load acting on it. Double acting cylinder. So in figure you can see this double acting cylinder. Double acting cylinder produce linear motion in two directions. Hydraulic power is applied on either side of the piston. The construction of the double acting cylinder is similar to that of single acting cylinder except that the rod end of the cylinder also has oil port. It has cylinder barrel, piston and piston rod. Both the ends are sealed with end caps which are either threaded or welded to the main cylinder. In some design, the end caps are held with the cylinder by the tie rods. The piston is provided with piston seal while the rod is provided with the seal, bearing and rod wiper, whose functions are same as those explained under single acting cylinder. Oil ports are provided on the either side of the piston so that the fluid pressure can be applied alternatively on both sides. Double rod cylinder. In this, the piston rod extends from both the ends of the cylinder. The piston is double acting type for which the fluid enters or leaves on either side of the piston. Such a design is more suitable for performing work on both the ends of the at a time. So it is doing work on both sides. Hence the operation is more efficient since there are two rod ends supported on the bearings. Such cylinders can withstand high side loads. Tandem cylinder. It has two double acting cylinders. So it has two double acting cylinders. So you can see two inlet ports are there, two outlet ports are there. It has two double acting cylinders with two pistons connected in series. Here the pistons are connected in series. A single piston rod is connected to the pistons. Such design are suitable for applications with higher forces is to be generated. When the load on the actuator is more, we are going to select this type of cylinders to do the work. Where higher force is to be generated using small diameter cylinders. Since the fluid pressure is applied on two pistons, twice the force is generated at the rod end. Such cylinders require pumps with higher flow rates for a given piston displacement, since the oil has to be supplied to the two cylinders. Moreover, the cylinder length is longer for a given stroke length as compared to the normal design. Telescopic cylinder. It has multiple cylinders that are mounted concentrically one within the other. The design is such that the innermost, that is smallest cylinder extends first, while the next cylinder extends after completion of the full stroke of the first cylinder. Thus, each cylinder extends in stage one after another. Each stage of cylinder has a sleeve that fits into the previous stage of the cylinder. The total stroke length achieved will be sum of the strokes of all the stages. So telescopic cylinders, such designs are used where long strokes are required with the short retraction length. For example, the hydraulic jacks used to lift aircraft, dump track bed riser, and so on. These cylinders basically work on displacement principle as explained in the earlier section. Next we will discuss cushioning. Cushioned cylinders. In certain applications, it is essential to deaccelerate the moving piston gradually. Means to reduce, we want to reduce the speed at when the piston comes at the end. So in certain applications, it is essential to deaccelerate the moving piston gradually at the end of the stroke. Such cylinders are provided with cushioning mechanism and are termed cushioned cylinders. Cushioned cylinders are used when delicate loads are being moved, or when the cylinder loading is gradually, or in some heavy cylinders to avoid damage of the cylinder itself at the end of the stroke. In operation until the piston spear retracts and reaches the recess. The free flow of the oil takes place through the recess. But as soon as the spear enters the recess, it blocks the free flow. Then the oil starts flowing through the restricted path, thus decelerating the piston movement. The check valve allows the free flow of the piston only during the extension stroke and stops the flow in the retraction stroke. Since the oil has to flow through the restricted path, large amount of energy is absorbed, giving a cushioning effect to the cylinder. The Dindal valve can be adjusted to vary the size of the restricted flow path, hence controlling the deceleration speed. So remaining type of rotary actuators we will discuss in the next class. Thank you.